Good afternoon.
So my name is Mingan Choct. I'm an animal nutritionist. So I did my PhD at the University of Sydney in early 1990s. So I was born in Mongolia, China, but I did chemistry. Then I did human nutrition, and then I ran a centre called Cooperative Research Centre for Poultry CRC for 14 years. So the Poultry CRC was a government institute that had a total of $180 million over 40 years. So that was finished in 2017, and then I took up the vice rector at university position. It's net energy in the world in the next 2 to 3 years. And currently looking at 90 million tonnes of poultry meat produced. And poultry is already the #1 animal protein source for human consumption, because you have nearly 70 million tonnes of eggs produced in the world. So Indonesia's still got a very long way to go in terms of poultry meat production. And 260 plus million people here. And if you increase the consumption by 1 kilogram per capita, and that means a lot of money, a lot of industry, a lot of research. So if you look at energy, it's measured, the basis for feed formulation, but measured as ME, metabolizable energy, often fails to correlate with animal performance. So the energy measure you use to formulate the feed doesn't actually tell you a lot about the animal performance. So here is a simple picture here. So this moved a little bit. G, gross energy. So total amount of energy contained in feed to metabolizable energy. So gross energy, normal feed, you have about 18.4 kilocalories. Then undigested energy through the urine and feces, it's about 4.5 megajoules. Then you have what's left behind is digestible energy. Then after digestible energy, you also lose energy through urine, here. Then you have metabolizable energy. So from 18.4 megajoules down to 13.1 megajoule. So if you just look at simply, gross energy to metabolizable energy means that you lose 30% of the feed energy. So roughly 70-30 split. 70% of the energy is metabolized, 30% is lost through feces and urine. Okay, so this is important. This is an important figure to remember. But no one now, if you look at no one formulates feed based on gross energy, because you lose 30% of the feed energy. Economically, it's not very good to do it. So no one, you don't formulate feed based on gross energy, eh? Now, this is the most important part of why net energy is done, why net energy is important for us in the future. From metabolizable energy to net energy, you also lose roughly 30% of the energy. So same amount of energy is lost. And that energy is lost through heat. So you're sweating, when you eat, you sweat. When animals move, they're generating heat. And if you walk into a chicken shed, it's almost like little heaters on. It's very, very hot. That heat is coming from your food, coming from the feed, and you're wasting money, you're burning money. Well, that is 30% of the energy. So, gross energy to metabolized energy, you lose 30%. Again, from metabolized energy to net energy, you also lose 30%. But today, if you look at the global feed industry, which is a massive, massive industry, very few people use net energy to formulate feed. They're ignoring the 30% loss. Just imagine if you capture, if you save, if you accurately predict part of that 30% loss, how much saving you can have. And you would become an instant industry leader. So why not use net energy? It's very difficult to generate net energy data, as the data is tedious and costly. And our project cost $2.4 million. And it's very costly. It's 8 years of work, and we had a team of people working on it. One cannot come up with any table for feed ingredients without developing prediction equations. So you cannot actually basically come up with a table and say, okay, I'm going to just check out the table and do it. You have to predict it because it's a dynamic energy. It requires a lot of moving parts. ME values are an important basis for predicting NE, and there are numerous issues with the ME values used in major feed tables. People formulate feed. There's a multi-billion dollar industry in Indonesia. You have Jaffa Confeed, you have Malindo, and you have CP. There are very big feed companies based in Indonesia. But a lot of people, if you actually go there and ask them, where did you get your table values for ME? A lot of them do not actually know. We don't really know. No, we picked up from different people, different tables. So there are issues with accuracy. There may be some vested interest for some people who are against an ND system. There are people out there who are selling computer programs. Those computer programs are based on ME, not any net energy. So these people will say, okay, if another system comes up, I will lose my business. So you better go out and tell people that you do not use NE. So that's the vested interest part. And I come across that quite often. So net energy methods. There are two key methods. The first one is indirect calorimetry. So you can actually open circuit and closed circuit system, two different systems. So that's our systems. We have 24 chambers. Each of these chambers is all sealed. You have 2 chickens in them, and it's measuring every breath that comes out of the chicken and every bit of oxygen that chicken consumes. The sensitivity of the equipment is extremely important. For example, if you take this room as a chamber, if I breathe, the meter will register it. Just imagine how small the amount of volume of air comes out of my mouth compared with the volume of this room. So that's also sensitivity you're looking at. And that's why I think we took 2 years to actually get the system right. And otherwise you would get wrong data. You rubbish in, rubbish out. And the other one is comparative slaughter. So you basically feed 2 groups of animals. One group, one type of diet, the other group a different diet. Then you kill the animals at different stages and measure all different types of tissues accrued in the animals. So how much muscle they burned, how much fat they burned, how much gut tissue they burned, they accrued. Then work out the energy levels and see how much of the feed energy is actually utilized by the animal. Again, it's not very accurate, very, very difficult to do. So we are talking about heat increment. So that 30% of the energy from metabolized energy to net energy is lost, heat increment. The heat increment loss during the process of digestion, metabolism. I'm sweating here, I'm losing energy, and I need to lose more, I think. But so that's talking, I'm losing energy. So the only time you lose very little energy is when you're sleeping.